In this video, we're going to go over the basic concept of projectile motion. So previously, we looked at the concept of free fall. And in free fall, you have an object that is falling only under the force of gravity. And it could be dropped or you could throw it straight up. When we're talking about projectile motion, we're talking about an object that is not only falling or thrown up, but it's also moving sideways. So where free fall deals with one-dimensional motion, projectile motion deals with two-dimensional motion. So it is also only under the force of gravity, but in a projectile, it will also be moving sideways. So examples of that would be if you had an object that you throw off a cliff, this would be a projectile. If you kick a soccer ball off the ground, that would be a projectile. So in both of these cases, not only is it moving up and down, it's also moving left to right, horizontally as well. All right, so let's take a look at an example here. So we're going to start off with the really tall cliff here, and we're going to throw a stone with a speed of 8 meters per second. Okay, now if there was no, I want you to do a thought experiment here. If there was no gravity and you threw this stone, it would move to the right at constant speed. It would just keep moving to the right at constant speed. Now, if you took this stone and you didn't throw it to the right and you just dropped it, what you'll find is that the stone is going to speed up as it goes down. So this would be a free fall motion here. Now, if you connect these 2 points, here's one right there, connect these 2 points, what you're going to get is the trajectory of this projectile. In other words, you're going to get the path of this projectile. And one more over here. Okay. And each of these circles represents 1 second intervals. So by drawing kind of a best fit curve, let me get another color here. If I connect these dots together in a curve like that, you're going to get the trajectory or the path of this projectile object. Now, what you'll notice is that horizontally in a projectile motion, that the velocity is constant. So at all points of this projectile falling, the horizontal velocity is going to maintain a velocity of 8 meters per second. Now, vertically, it's going to behave like a free fall object that you just drop straight down. So vertically, it's going to accelerate downward. And we know free fall acceleration, the acceleration due to gravity, is 9.8 meters per second squared, or about 10 meters per second squared. So what that means is every second it's going to increase its speed by 10 meters per second. So this is 1 second after it's thrown off the cliff. This would be 2 seconds. At 2 seconds, it'll have a vertical speed. It would have a vertical speed of 20 meters per second. 3 seconds, it'll have a vertical speed of 30 meters per second. At 4 seconds, we'll have a vertical speed of 40 meters per second. Okay, so we want to go ahead and summarize what we have here. So in summary, the horizontal motion, a projectile object will move at constant velocity, and vertically, okay, the vertical motion of the projectile, you'll see that it will accelerate at approximately 10 meters per second squared, and it will be in the down direction. Okay. Sometimes you'll hear people talk about projectile motion and to say that the horizontal motion is not affected by the vertical motion. Horizontal motion is not affected by the vertical motion. What that means is that even if you were to throw the ball with a greater speed horizontally, the vertical motion will still accelerate at 10 meters per second squared. And even though that the ball is falling and the ball's speed is changing as it falls, horizontally, the velocity is constant. So therefore, we say that horizontal motion is not affected by the vertical motion, or that we can sometimes say that is independent. The horizontal motion is independent of the vertical motion.